Hi everyone, thanks for coming to this talk titled Hotfix Heaven, Why In-App Updates Are a Must. Brief introduction to myself. My name is James Cullimore. I'm 34, Irish, married with 2 children. In my spare time, I do MMA. It's a good alternative for keyboard-related incidents. Turns out smashing punch bags is a lot cheaper than smashing keyboards. I've been an Android developer for roughly about 8 years. And for the past 2 years, I strive, or a little bit longer as well, I've been striving to give back to the community by posts on LinkedIn, open source projects on GitHub, and articles on Medium and so on and so forth. Throughout the QR code, when you scan the QR code, you'll come to my website where all my publications can be found. And, sorry, a little bit nervous. Yeah, throughout the whole slide, there will be other QR codes, just relevant information to that slide. Feel free to scan it during the talk, but you'll also be provided at the end a list of all the links. So, today's agenda, we're going to look at, first off, what in-app updates are, for those who may not know what it is. And we're going to look at the 2 flows that are available to us, being the flexible and the immediate flow. And of course, for the clickbaity part, why in-app updates are a must. And I'm also going to share a couple of personal stories, experiences that have happened to me over the last few years. And then we get into how to add this to a project if you haven't done so already, or maybe improvements to it as well. And then looking into 2 sorts of triggers to it. So we have the Google Play Publishing API, but we also have a different way of triggering it, which is the Firebase Remote Config. After that, we'll look into different ways of testing, because there is more than one. And lastly, for the implementation, we're going to look into just some troubleshooting stuff that I've come across over the last few years as well, and after some research. For the last 2 parts of it then, we're going to look at some statistics, which may help, may not, who knows, and some strategies as well to help find the best methods for use when you're using in-app updates. If I speak too fast, this is unfortunately because of my accent and nerves. The advantage is when the videos come out, you can play it at 0.75 speed, probably with subtitles as well, just in case my accent's too thick. And yeah, let's jump into it. In-app updates are a Google Play Core library. It used to be bundled together, now it's separate. And it delivers updates more promptly to your users. It can also be used as reminders for users that an update is available, all within the app itself, which means the user has the comfort of never leaving the app. It's available for Android 5.0 and higher, so APK 21, and it's available for mobile devices, tablets, and Chrome devices only. It supports APK files and AAP files, but unfortunately, no support for OOB. Next, we look into the 2 sort of flows that are provided for in-app updates, one being flexible flow, the other being immediate. For the flexible flow, you'll see here on the right-hand side, it's big enough. The user has a couple of options. So the first you'll notice is that it comes in the form of a bottom sheet dialog. And the app is visible in the background. So the users have the options of clicking it away, clicking on what's new to see the release notes. That means our release notes are a bit more visible. More info leads them to the App Store. And of course, if the user clicks on update, we'll come then to our second screen, the one in the middle. You'll see down at the very bottom, Blobby just downloaded an update. This is basically us within the app also prompting the user to finish the update. That means that the user can click on update, continue using the app, and whenever the user is ready, they can then install the app. So this could be an hour later. And when he does click on update, then we'll have the final splash screen, the one on the right. And this flexible flow is very similar to our immediate flow, except there's no screen in the middle. So this is normally used to block the user from continuing into the app. It's ideal for critical fixes and security patches and stuff like this. Normally we would block it, as in if the user presses on cancel, we simply show it again. So why are in-app updates a must? Well, First one is, it ensures timely delivery of our updates. So automatic updates, when they're active, it could take a couple of days before the actual update comes to the users. However, if the user has manual updates or the automatic updates inactive, that means it could be that they don't get the update at all. We'll come to that later. Because we have the option now to show in-app updates and bring more updates to the users, ensuring that they're getting the updates, this will naturally increase the engagement of the retention due to the content of the updates themselves. It's an enhanced user experience. The user goes into the app, never leaves the app, gets prompted there, and continues on, which means when they cancel as well, they can just simply continue. Builds trust with the users too, because they know as well where the update is coming from. They don't have to then go separately or find it themselves. And it allows us strategic control. So we have control over our own API migrations and code migrations. And as well, there is the case of being able to avoid a penalty in a regulated environment. For example, if we have a health app and there's been some sort of data breach, well, we want to try and get a security patch out straight away as fast as we can to avoid said penalty. And we can do that by using in-app updates. Now, a couple of stories from my side, because something like that has happened to me, and on more than one occasion. The first one is my own fuck up. I'm going to be very honest with you. I was working on, to keep it simple, a data migration based on a couple of conditions. And I'd even wrote unit tests, but unfortunately, it didn't work out. So when I released the app, there was a spike in crashes. It wasn't just a spike in crashes, it was a bad migration, basically. So I had to fix it straight away. And one way of utilizing the in-app updates was that I was forcing all the users to click on the newest update. So they never got the bad one in between, which thankfully only a couple of users were affected. The second time this occurred, it wasn't just me, but it was the whole team. We were working together on a new app and a new API. We were bundling all of our experiences and resources. And after a few months and a few versions and a few changes, we realized, some of the older versions are crashing. So we looked into it, and what we realized was we weren't versioning our backend. So any refactoring or data model changes or endpoint changes, of course, were crashing our older apps. So we had, thankfully, in-app updates built in, and what we set was a minimum version that the users had to have update, which allowed us then to keep our backend versioned without actually applying versioning into our backend. The last story, where in-app updates saved my arse, or our arses, was a completely unforeseen one. So we had added certificate pinning to the app for security enhancement. And over Christmas, the certificate issuer got hacked and revoked all of their certificates, including ours. So our app was, of course, not communicating with our API anymore due to the certificate not working anymore. And of course, we had the smart idea as well. We had maintenance mode built in, but on the same API, which wasn't communicating with either. So it was like, we had to pull that out then separately as well. So there are 3 occasions over the last few years where just alone having immediate app updates within the app as a safety net was a high advantage for us. So if you want to add this into your app and you haven't already, I'm going to show you how to do it. Straightforward. First thing we need to do, we need to add our Gradle dependencies, optional our Kotlin extensions, which I would advise to use. And then we'll create an instance of our app update manager, and we'll add an on-success listener. And here we will check whether an update is available, but also check if the update type is allowed. There's a little bit of controversy about that, and I will come to that later. The is update type allowed? But here we'll check if our flexible flow or immediate flow, but like I said, I'll come to this later again. What we can also do is we can check for the client version staleness. So this is the equivalent of when the app found out an update is available, and we can also set, okay, well, we're not going to show it straight away. We want to maybe have a back off of 3 days, 7 days, whatever. And this is how you would set it. We can also set the priority. By setting the priority, we can base which flow we show and how much backoff we have as well, based on the range that the update priority is. It's a range from 0 to 5, 0 being default, pretty much never used. But you have up to 5 choices. Tends to only use 2 or 3, but we have the option at least. And once all the conditions have been met, so an update is available, we're allowed to install it, we then start the update flow. We pass over the app update info and our activity result launcher, and of course we build our app update options, whichever flow we want to use, whether it be the immediate or the flexible. We can also set allow asset pack deletion to be true. It is per default by false, and there's a good reason behind that. What it does is it deletes any assets to allow for space for your update. It could be that the phone doesn't have enough space, so it'll delete some assets to allow for the update to be downloaded. If, however, some of these assets are being used by the app and the app is started, the app could crash. So be very wary when using this. And for our activity result, or what we registered for, here we can check whether the update has been installed or cancelled. So if the user does actually click on next, we do get that feedback, which is good. But we also have a result in-app update failed. So we can check as well for the result code to make sure why did it fail. And of course, we can handle this accordingly by informing the user for a good UX. What we can also do is on the fly listen for how much our install status and as well how many bytes have been downloaded so that we can show an update progress bar. And this is optional, of course, but it's a good idea as well. We can also log the states or simply install the update depending if it's downloaded. Make sure to register this listener before starting an update and unregistering a listener when you don't need it anymore, otherwise you'll have some memory leaks. Any entry points for the app, we want to check if the install has been downloaded. And if it has been downloaded, in our flexible flow, in this case, we will simply show a pop snack up bar, comes on the bottom, or maybe a button which just says install. For error cases, we can show the exact same snack bar and say with a button, retry. In cases, for whatever reason, that the download failed or has been stalled, for example, you might lose internet, for any other reasons as well, it has been triggered, but it hasn't been completed. So we do have this state as well, through the update availability, developer triggered update in progress. And when this happens, we simply start the flow as we had beforehand, and everything will continue on. So that's all we need for the apps. So how do we trigger them? Well, there's 2 ways. First way we're going to look at is what's also documented, the Google Developer API. And this is split into 2 parts, the subscriptions and in-app update, in-app purchases API, which we're not going to look at, and the publishing API. Now, the publishing API can be used for uploading new versions of the app, also editing some of the APKs on the various tracks, like the alpha, the beta, and also modifying your Google Play Store listings. But more specifically, what we're wanting to look at is the edit tracks update method. And here what we have is the option to change the app in-app update priority. So here you can change the value to your 5, 4, 3, 2, 0, 1, 0. This is the only thing we change. We don't change anything else. We don't say which flow we want, for example. And we can only change it if we haven't completely rolled out the app, which is also a bit of a restriction. So who controls this power? In most cases, the team does, which is fine. It's an API. We know how the APIs work. In my case, I do a lot of freelancing. So when I've done this, I tend to hand it off to someone who's not a techie person. And I get this reaction. Because, what the fuck? Yeah, they have no idea how it works. And of course, it's very difficult for me to try and explain to a non-techie person how an API works. So we need a simpler solution. And in comes Firebase Remote Config. Now, for those who don't know what Firebase Remote Config is, I'm now forgetting my speaker notes. The one line I'm forgetting all the time. We can change the appearance and behavior of the app on the fly. That means we don't have to release new updates to change said behavior and appearance. We utilize also key value data store, so we can send over strings, booleans, numbers, and even objects for our remote updates. And we can also target certain user groups. So we can use it in a slight A/B testing as well, or only target our updates or remote configs for specific users. And it also offers offline caching. So it's ideal for us. So if you're going to add it in, if you're using if you're using other services from Firebase, which I imagine you would be, we can use a bill of materials and just then simplifies everything else afterwards, and simply add in our Firebase config. We will then create an instance of our remote config, and we are going to set our minimum fetch interval in seconds to 3,600. That's 1 hour. Per default, it's set to 12 hours. Don't leave this in. You don't want to leave it at 3,600. This is only for development purposes. And there's a good reason for this as well, why it's set to 12 hours. There is a limit and a throttle. I will come to that in our troubleshooting section. And what we'll also add here is our defaults. So we want to, in the cases that remote config hasn't worked or we're offline or for whatever reason, we can still have our default within the app, which it falls back onto. And this we will add to our app under our resources values or resources XML. You'll see here on the very bottom the blue file. And in this case, specific case, I've added entries of minimum flex version and minimum immediate version. You can structure this however you want. I have done it in different ways depending on the project and depending on the person who's using it as well and how they want to use it. Keep it as simple as possible, basically, especially for the updates. And after we've added this, we simply fetch and activate. And we'll see then if our remote configs have come in, if it's successful, and we will then handle our show update flow. So we will utilize the data here as well. So we need to make one last code change to our app, and then everything works. We'll come to that in a second. We can also handle error cases, or at least log it, whatever you want. This is normally done when the app is also created, but we can also listen to these changes on the fly. So if you have an app that's maybe running for a couple of hours and you want to change your configurations, or at least that the user get these configurations while they're using the app, this is a way of doing it. We would have our listener, and we'll inside or on update or on error, we would have it just as beforehand. But also check if the updated keys are still there. It could be that the remote configs have been deleted or changed so drastically that it also breaks the app. So be wary of that too. So now comes the final change to our app. It looks a bit complicated, but I'll go through it. We're supporting, let alone the Google Play API, we're also supporting Firebase remote config. So now we have two ways of being able to trigger it. And you'll see in the second white highlighted line, we're getting our remote config instance, we're getting our version, the double or the number, and in this case, in our minimum immediate version, and we're making sure that this is more than our current version code, therefore it will trigger an immediate app update. So this is all great, but how do we test it? Well, one way of doing it, YOLO. Fire it up. No, you don't want to do that. But we're going to go a couple of tracks below it. There's one track called the internal sharing track. And this is the way how you would manually test in-app updates. So you have to, first off, activate it. And you do so by going into the Play Store, menu, settings, tap about 7 times, activate the setting, and voila. Very similar to developer settings, which most of you might know. Then we upload our app version. So in this case, version 1. With our in-app logic already built in. And we will install said version on our device via the app sharing URL. And we'll then bump our version. So if we had version 1 beforehand, we now have version 2. And we also upload this app to the internal app sharing. Make any required changes to remote config or Google Developer API, which is a little bit tricky, but we'll leave that out for now. We click on the sharing link, but for obvious reasons, we don't want to install it because then it's updated. So what we want to do is just click on the link to inform the app an update is available, but not to install it. Then we simply open our current version of the app, which would be version 1, and this should trigger our flow. Now, if you're like me, you might have to do this a couple of times, and that can be incredibly annoying because you're building the app, pushing it up, downloading, you might make a mistake, you have to do it again, and this takes time. And in my case, I was on version 8 before it actually worked, so a bit of a nuisance. There's a better way. By utilizing Fake App Update Manager. Great for integration tests. It is a fake implementation of the App Update Manager, which is completely self-contained. However, no UI is shown. Now, our UI is shown in an integration test, but the UI from the in-app updates, so this dialogue and the splash screens, these are not shown. But that's fine. We don't want to test that. That's an external dependency. We only want to test error logic. No update is performed on the device itself because it's a fake. And it's perfect for testing, initiating update flows, checking download progress, any UI changes on our own app, and also handling all your failure scenarios as well as any back off or staleness. It is not intended, though, for full stack integration tests. This is not a test you add in and then run on the pipeline constantly. You're not looking here to get your code coverage. It is literally just to test the logic. So you would normally add it in, run it, and then maybe add and ignore or delete the code, whatever you like. To do so, in our tests, we would have a setup where we create the instance of our fake app update manager with our target context or instrumentation context and simply inject it into our app update manager factory. So it's very straightforward. And in this test, we are testing the flexible flow. So we need to inform our update manager which flow we're testing and set the update available. And in our case, if the app version is 1, then we're setting the update available to 2. If your app version is 88, then you want to set it to 89. And we'll launch our scenario, either our activity scenario or a composable scenario, whatever you want to use to launch your activity. We can then start our asserts, and we can simulate the user's behavior. So if we want to simulate the dialogue, what the user would click on, this is the best way of doing it. And you can then say, for example, download starts. If you have any UI changes, you can then also make some asserts here to ensure that you're showing your views. In this case, we've just skipped this. We've gone straight to downloads complete. And afterwards, once the download is complete on our flexible flow, you saw in the 3 images at the very beginning, we had this little snack bar with the button install, and that's what we're going to check here now. And we're also going to click it. So we're not checking if it's a retry, but we are checking if it's an install. And once we click it, then our install splash screen should be shown. Here we make a further assert. After that, the install is complete. Perfect. All good. The same goes for the immediate. There's a little bit less code here because in the immediate, you don't have any extra UI changes that you're wanting to show to the user. Instead, here it goes, once the user clicks on update, it goes straight to the splash screen. So we're testing only here maybe if any errors happen afterwards. Now, how do we do that? Very straightforward as well. We have download completes and we also have download fails. And in cases of a download failing, what we can do is check if our retry button, so it's also a snack bar, and click it. We can assert false, that the install splash screen is visible. And then in this case, we want to restart the actual, we have a retry button. So obviously what we're wanting is that the dialog comes up again. In this case, we can make a confirmation that the dialog is visible. So over the years and after some research, I noticed that there was a couple of issues. And one of the first ones that came up was this is update type allowed? And you have no way of setting this remotely. So there's no way of saying, I want the flexible flow or I want the immediate flow. It's all based normally on your priority. So it's a bit confusing. So reports online then said that this is completely redundant. That's not really the case either because it also returns false when the device space is low or when it's offline. So it's not completely redundant. Might be named badly, but it's a bit confusing. Something that's happened to me quite often as well is excessive update flows and checks, so that when the app actually starts, we need to check that our back off and staleness is actually working as it is, and that you're also not showing the update flow every time the activity is on resume, for example. That mistake I also made myself. We don't want to pester our users. We want to give them every opportunity we can. We don't want to pester them. We don't want to block them every time either. I've also heard reports of the remote config changes not being visible after you've changed it a few times. This is where we have this limit and throttle. So within the time frame that we've defined, which is 3,600 seconds, 1 hour, you only have roughly about 5 requests. So if you made your 6th change within that hour, you will not see it until the hour's up. It's the throttle limit that's jumping in. There is a link afterwards from Firebase giving all the details about this. Especially if you've left it at 12 hours, then during your development throughout the day, it could be that you've reached this limit. And lastly, if an update is for whatever reason not visible in the store, be it on the internal app sharing as well, this could be due to simply the cache not being emptied. So Google Play Store tends to cache everything and not empty it very often. One way of doing it, either wait or empty the cache. Very easy to Google that, and your update then should be visible. So, moving on to some statistics to try and help us wrap our head around everything too. And one of the first ones I want to show you is, it's a poll from Android Authority with their 25 plus million views. I don't know how many people actually did the poll. But their poll was how many people have automatic updates deactivated. And it's 35% of their readers, or the people who took part of this poll, which was, for me, a fucking huge amount. And it struck me as a bit too much, so I decided then to look into one of my apps which had a bit more data. And you can see it. Yeah, you can see it pretty decent enough. This is basically a release life cycle of about 6 months, 4 releases on one of my hobby apps a while back. And you'll see in the first release that within the first few days, the app got installed, which was great, and only very, very slowly got closer to the black line. So basically this light blue line is the version that got installed, and the black line is any previous versions. And this whole time frame is roughly about 60 days. And for every release cycle afterwards as well, you could see there was always this sort of discrepancy. So when you look into the data a little bit closer, we'll see that from the over 1,000 users or 1,100 users, roughly a little bit over 10% were not on the newest version after 30 days. Some of the users were using a version so old, I was baffled by it. It was roughly about a year and a half old, which meant they had massive security issues and features weren't even in it, a lot of bugs, but they were still using this version. And this is active users. So then I thought to myself, well, if they don't have the updates, then this could be a good potential reason why people are uninstalling an app. So in cases of games, it might be too boring because you're not delivering content. It could also be performance issues that you haven't been updated, or maybe you have fixed but haven't given to the users yet in somewhere in the form of an in-app update. And there's many other reasons then as well. So what we want to do is we want to find the ideal update frequency, so how often we deliver this update, but at the same time not so often that we're blocking them. And the shit answer is there's no one size fits all. This is a really shit answer. I didn't like that myself because it all depends on how many devs you have available to you, some sort of time constraints, bugs come in, you have reports to give up. There's market demands, the app type, and there's also the user feedback as well. All these things have an influence on your ideal update frequency. So it's not great. And because this is a shit answer, I want to then give you 3 examples, in my opinion, what would be the ideal frequency. And of course, because it's different apps as well, we're going to start off first with a banking app. So it's used maybe on a weekly basis, roughly for 10 minutes. So in my opinion, the ideal interval would be monthly. This allows then developers to get as many tasks done for the update, but also enough time frame that it delivers enough content and fixes and performance issues for the user. What a frequency cap is basically that we don't go over this. We don't try to bring out too many updates within, for example, a weekly basis. And we have then, let's say, a back off of 3 days. What a back off would be in this case is that if we do have the app update on the store, we don't show it directly to the user. We wait roughly 3 days. Then we show it. This allows then the first 70-80% of the users to install it through active updates, or automatic updates. And we only show it to those who haven't gotten it yet or have manual updates active. The next example would be a social media app. This would be something you use a bit more on a daily basis, up to maybe 1 hour. So something like Instagram, Facebook, anything similar to it. The ideal interval here will be bi-weekly to monthly, depending on the resources you have, because the content here is normally generated from the people. So we don't have to worry about the content. We just have to worry about maybe bug fixes, extra features, stuff like that. And the cap then as well will be daily. Now you're seeing a slight little pattern here as well. The usage and the frequency cap tend to be the same. So if your users are using it on a weekly basis, on a daily basis, we don't want to block them every single time they come in the app. So we want to try and push it off a few times. And our back off here will be 7 days. Like I said, it's not as critical for a social media app as it would be, let's say, a banking app. Banking app needs to be more secure. Social media apps, not so much. And the last example will be an idle game, where disused every 2-3 days, maybe about 2 hours. So the ideal interval here would be weekly, bi-weekly. The reason being for this is your updates are probably going to be filled with content for the users. So this is to prevent them from getting too bored. And then we have a frequency cap, again, similar to beforehand, daily, because they're using it every 2-3 days. So it's roughly the same. And a back off then again, 1 day, because we want to ensure that they really do get this content. Then we have to ensure as well that our in-app updates are shown every time. That would be what I would do. Looking at what the top 1,000 apps on the store do, they make releases on average within a week, 25% roughly. And on a monthly basis, 63%. And 94% on an annually basis. But again, this is all types of apps, whether it's a game app, social app, banking app. So it's not nice and dandy statistic, but it's not really helpful. What is helpful are maybe a couple of strategies for you that you can utilize for your in-app updates. First one being, and what I see very often is that in-app updates is in the app, but not used. So they're only there for a safety net, which is great. I've given already examples of why it's good for a safety net. But we could be using them all the time. I mean, we have possibly a range of 10% to 35% of people who don't get updates at all, or way much later. So start using them. And ideally from the start. What we can also do is we can track the metrics. We can see then what users are installing them, how they're installing them, are they canceling, when it's been shown. We can track all that and we can then adjust it to be more appropriate for our app. And if you don't want to do this for all of your users, then utilize A/B testing. Only bring it out for roughly about 5% of your user base. And get feedback regularly. You don't have to talk to the users directly, but they do also leave reviews, or you can use something like a service called Servicate to get feedback from your users about specific features even. And ask them, hey, was this an app update a nuisance for you, or was it okay? You can then prioritize your tasks a little bit more accordingly to this feedback. And utilize app bundles. Because with app bundles, the update is going to be a bit smaller, and therefore also a bit faster. Which means then our in-app updates, when it happens, then it's quicker altogether. It's nice for the user. So aim for value with every release. What I mean with this is, when you do have a release cycle, try to adjust it that for every single release, the users have value with the release. That means that it's not just minor bug fixes that only affect 1% of your user base, but maybe you leave it off for a little bit and bring something a little bit more for all of the users. And lastly, we need to clearly communicate. That means with our in-app updates, our release notes are a lot more visible. So it's good if we can communicate this, what actual changes have been made, and not just simply say, we've updated our app, fixed some crashes and features, and then repeat this every single time. No, we can actually clearly say to them, hey, the crash in around our specific activity has been fixed, or new content has been added specific to this part here. So in summary, we now know what in-app updates are, why they are a must, we know how to implement it, and how to trigger them in 2 different forms, and an ideal way of testing, not just a manual test, but also integration test. We also know that not everyone gets updates, be it 35%, 10%. You'll have to look at your own app metrics to find it out. Very, very simple. And hopefully you also have a better insight into the frequency of how often we should be releasing app updates and our cap off. And of course, strategies for a better impact. Here are all the references throughout the slides. So all the links parts of it were QR codes, also good content to read, some of articles as well that I came across while doing my research. And the very last link is from Academy Droidcon. There we have an interactive video tutorial how to add in-app updates and utilize Firebase as well if you'd like to check it out, along with much, much more other content. Thank you very much.